Right, we're going to take a look at the general solution to trig functions today. So we'll start off a recap of particular solutions because general solutions involve these and they're a bit trickier, a bit more complicated, so this video is a little bit longer. So the answer to this one is x equals pi over 6 or 30 degrees. But this is just one solution and there are many. So here we go, here's the solution, pi over 6, 30 degrees, but as you can see there's another solution and another and another, and it just keeps going because that's how trig functions work. If there's one solution, there's going to be many, and it goes backwards as well. Okay, so let's just take a quick look at the different values of pi, because if we look at where we've got the x equals 0 line, we'll see that the solution is pi over 6 to the right of that. Now we move it to pi, you can see that the solution is pi over 6 to the left of pi. Right, move it along again, so here's pi is equal to x equal to 2 pi. The solution once again is to the right by pi over 6. So 13 pi over 6 is pi over 6 to the right of 12 pi over 6. And it goes along, it moves to the right, then to the left, then to the right, then to the left of the integer values of pi. So that means that we've got the values of x when pi is equal to, when we've got 1 pi, that's going to be pi minus the particular solution. Then we've got 2 pi plus the particular solution. Then we've got x equals 3 pi minus the particular solution again. And then we've got x equals 4 pi, 5 pi, 6 pi, 7 pi, whatever, goes on to n pi. And we're always going to be putting on this part, the particular solution at the end, and it's going to be plus minus all the way along. So we're going to be either adding or subtracting in order the particular solution from our values of pi, because that's how the general solution works. Including, not to forget, 0 pi, that will be the particular solution just there. So it starts as a plus, then a minus, then a plus, then a minus of this particular solution of the angle. Right, so we're going to write this as n pi for any value of n, which is an integer. And then we're going to do this negative 1 to the power of n thing, which when n is 0, so it's negative 1 to the power of 0, that's 1. Negative 1 to the power of 1 is negative 1. Negative 1 to the power of 2 is positive 1. Negative 1 to the power of 3 is negative 1. So it just goes 1 minus 1, 1 minus 1. And that just makes it a plus negative plus negative. Right, so if we've got sine of x equals to 0.5, then sine of theta equals alpha. Alpha is just our answer that we're, well, just what we're trying to make our equation equal to. And we rearrange it to find the angle by itself equals the inverse sine of the right hand side, and then we can plug this particular solution in terms of the angle anyway into our general solution, which is n pi plus negative 1 to the power of n times, then there's the particular solution, and that bit there is the general solution part. Add them together and then you can just plug in any values of n. N has to be an integer though. 1, 2, 3, 4, 0, negative 1, negative 2, they're all good. Any values which are whole numbers. Right, so here's an example. If sine of theta equals 0.2, well, theta equals inverse sine of 0.2, so that's like your particular solution part. You've got the angle by itself. That's when you go to the general solution, you plug in the formula, and that will give us all these values here, all the values for which 0.2 is equal to sine of x. Right, so the first one is about 0.2 above 0 pi, then the next one will be 0.2 below pi. So here's some of the values. I'll just plug in the general solution here. Inverse sine isn't working, I think. Right, so arc sine is the same thing. So if you see arc sine or inverse sine, it means the same thing. So here's arc sine of, that's your general solution right there. And here's the values of all the answers. That's all the answers to this equation. Let me just plug in, there they are. Right, so I'm just going to compare it to the values of pi. So there we have just a little bit above, a little bit below, a little bit above again, a little bit below the integer values of pi, above, below. That's the plus minus part at work. Alright, so here's a slightly tricky example. This time our angle is a bit more complex. It's not just x or theta inside that sine bracket. So here's our tricky example. So first things first. Right, so just like usual, just like last lesson, we have to take the particular solution. What I mean here is just get the bit inside the brackets by itself. So it's a particular solution in terms of the angle, not in terms of x, but in terms of what would be theta, the whole angle inside the sine. So I'll get rid of my 2 on both sides. Now I'll divide both sides by 3. And lastly, I'll need to do the inverse sine to both sides, and that there will be my angle theta inside the sine bracket. So theta is equal to that 2x minus pi over 3, and that will be equal to, so we'll call this a particular solution. It's not as such because we need to rearrange for x, but that's our particular solution in this case. Right, so it's at this step that we now have to get the general solution part. So we'll apply the formula for the general solution. This is in your formula sheet, and I'll show you that in a little bit. So theta is going to be equal to n pi plus -1 to the power of n, so that's your general solution part from the formula sheet. Inverse sine, and that's the particular solution bit plugged in just there. Right, once I get to this stage, now I've done my general solution, I still need to know what the answer is for x, and we haven't done that yet. We've only got it in terms of theta. So I just need to make sure that I take x by itself. So to do that, I'm going to need to, there's my equation. Make x the subject. I'm going to need to get rid of this minus pi over 3. So I'll add pi over 3 to both sides. There we go. And lastly, to get x by itself, I need to divide both sides by 2. Here we go. Takes a little while, a bit more complicated. That's why this video is a bit longer. And pi over 3 over 2, that's pi over 6. Right, that there is my general solution. If I just go ahead and plug in any value of n, that will give me the different solutions in order. And if n is equal to 0, that's what would have been my particular solution as well, my original solution, where this whole bit at the start doesn't apply. That would have been inverse sine of that whole bit plus pi over 6. And that's that first dot just there. And then the next one's going along. And we could go backwards as well if we wanted. Okay, so first of all, you have to get the particular solution. Once again, that is just the angle inside of the sine or cosine or tan by itself. Then you apply your formula from your formula sheet. If you don't remember it, you don't need to remember it. It will be in your formula sheet for your level 3 exam. Apply general solution, and then you need to just rearrange to get x by itself. And that will be your general solution. X or theta or whatever. Right, here's cosine. Slightly different. You'll notice it's a different formula. Here's your particular solution as last time, and this time the general solution is going to be equal to 2n pi plus and minus, so you have to do both for each one, for each value of n, plus n minus the particular solution. So if we just take a quick look at this graph here, so here's the solutions to this question just there, and we'll just leave in the 2n pi values, so 0, 2 pi, 4 pi, and so on. And you can see the solutions sit either side by the same amount. So that is, if you take 0 pi, you go up or down, plus or minus, by the amount of the particular solution for that problem. So here's an example, a bit of a trickier one, but we'll explain it using this. So just on the right, I'll get to the point where we've got the angle, the bit inside the cosine all by itself. Right, this is what we're calling the particular solution. although it's not in terms of x yet. We have to do that bit later. Right, so we've got our theta by itself, so that's 2x minus pi. That's going to be equal to root 3 over 8. Right, this is our particular solution just here. So that means that 2x minus pi is equal to, and I'll just plug in the general solution part here, plus, okay, so there's a mistake. That should have been inverse cosine of root 3 over 8. So it's 2n pi plus or minus inverse cosine of root 3 over 8. That's your particular solution part just there. Now we've got the whole general solution just now. I just need to rearrange for x, so plus pi to both sides. Let me just do that. And x by itself, everything divided by 2. Could simplify that, should simplify that. Right, and that there is your general solution for x. Often the question will ask you to find all the solutions on a range. So let's just say we're asked to find all the solutions between x, when x is between 0 and 2 pi, between or including, better put a greater than or equal to, but extra notation, probably didn't need the brackets. Right, so just plug in all the values of n into this equation here. N equals 0, 1, 2, and so on. Right, so if we take n is equal to 0, then we get x is equal to this. If n is equal to 1, then x is equal to this. N is equal to 2. Three, n is equal to 4. I think we'll just stop here because we're trying to find all the values between x is between 0 and 2 pi. So this last one here, there's 2 pi, it's about 6.28. That last one there falls outside of it. So that means these are all our answers. These are all the answers to this question that fall in that range. So that'll be the end of our answer. Lastly, the general solution for tan. This one's a bit easier to apply. You take once again you take the partial solution, particular solution, sorry, and then the general solution is just n pi plus that particular solution part. Alright, a little note, here's the part of the formula sheet with your 3 formulas for the 3 general solutions. And you see they've got an alpha here. We had an inverse sine alpha, or an inverse cosine, or inverse tan of alpha. The reason is that we've got this whole bit, sine of theta is equal to sine of alpha. We've been answering questions where sine of theta was equal to alpha. Seldom are you asked to solve sine of x equals to sine of alpha, or sine of 0.5 for instance, because x is just equal to 0.5. It's not too much trickier than that. We're normally getting it in this form, so x would be equal to the inverse sine of 0.5. So that's why in our formula sheet we see it with just an alpha, but really it's going to be used as an inverse sine of alpha, or inverse cosine of alpha, or inverse tan of alpha, because that's what the particular solution usually is. It's usually written in terms of an inverse trig function. You just need to be aware of this because that's how the formula is written in the formula sheet, but really you're probably going to apply it most times in the other version which we've done in the examples. So step 1, find the particular solution, like I've said, in terms of the angle, not in terms of x. So once you get rid of the sine or the cosine or the tan, that's when it's time to plug in your general solution formula. Next you have to rearrange it, so we've got x equals, so it's x is the subject of the equation, and then if you need to, plug in the values of n to find which ones fall within your range for x values. Right, now that's quite a bit more complicated than the particular solution. You will get used to it, but as always, you're going to need a bit of practice to make practice makes perfect, as they say. And that's the end of that.